Okay, so let's say 14. We have the cube root of 2x minus 6 minus 4 equals 0. One more time, we're working on page 630. So I'm asked to solve this equation, and my first question to myself is, what type of equation is it? Because if it's linear, I do one thing. If it's absolute value, it's a different thing. If it's radical, it's a different thing. If it's quadratic, a different thing, and so on and so forth. So what type is it? Radical, right? Good. So I have to isolate the radical. There is only one radical in this problem, so I will write the cube root of 2x minus 6 equals 4. And now, what power is the cube root? And you cannot say 3. Roots are fractions, right? Powers that are fractions. So when I say what power is the cube root, you will have to say 1/3. Okay. So then knowing that, what do I raise? I use the principle of powers. What do I raise both sides to? Yes, it has to be 3. 3 and only 3. 2 will not work. 4 will not work because only 3 will eliminate power 1/3. So what do I have on the left then? Right, that's clear. I have 2x minus 6, and the right-hand side is 64. Now this becomes what type of equation? Linear. I move 6, so I have 2x equals 70, so x equals 35. Of course, it comes with a question mark. Yes, I have to be honest with you. As long as the index is odd, solutions will work. Because odd indices create no problems. No problem inside, no problem outside, no problem, period. But I still have to show that I checked. So I have to go back to the original problem. 2 times 35 is 70. 70 minus 6 is 64. The cube root of 64 is 4. 4 minus 4 is 0. And I'll say yes. But the principle of powers requires us to show that we checked, even if the index is odd. Okay, so let's look at 17. And I'll let you choose. If you have your book or if you would like to choose, please let me know. So again, I'm hoping to finish both sections tonight. On Thursday this week, I'd like to review everything again and give you time to work on the homework over the weekend. And on Tuesday, I'll answer your questions. We'll go over material again, and if we can, we'll start something else that will not be on the test too. If not, we'll review. Okay, so any suggestions here? It is a yes, say it again. You want to move x to the other side, right? So here's what I recommend. If I move x to the other side, then definitely I have to multiply everything by -1. There are too many negatives in there. The other option would be to move this radical that has minus in front here, and this number that has minus in front here, and everything will be positive. It doesn't matter. If you move x to the other side, you will have -x. You will multiply both sides by -1, and you will get the same thing. What will be my next step then? Right. I have to be very careful. The right-hand side is nice and easy, which is... But remember, we have an agreement for the left-hand side. It's very easy to miss this and just say x squared plus 64. That would be a terrible mistake. So what do we have on the left?
X squared, 16.
That's it. Now, what type of equation is this? I started with the radical, but now it collapsed, or it changed, if you want, into what?
Quadratic.
Yes, quadratic. So now I have to dig deep. and say, how do I, or ask myself, how do I solve a quadratic equation? What do I have to do? Exactly. So I have x squared. I have to add 3x, so it's positive 19x. And I have to subtract 4, so it's positive 60 equals 0. Since the leading coefficient is 1, this should not be too difficult to factor, right? So I'm looking for two numbers whose product is and whose sum is. Since everything is positive, those numbers have to be positive. So, but what is the product equal to? Very good. And what is the sum equal to?
19.
Very good. So let's see if we can come up with two numbers whose product is 60 and whose sum is 19. Not too difficult, I would say.
15 and 4.
Excellent. So then I have directly, there is no need to use factoring by grouping because the leading coefficient is 1. We are going to review this in the next section. So when we finish with this chapter, I'll give you a handout for chapter 6 and we'll review the entire chapter 6. So because the leading coefficient is 1, I can use 15 and 4 and it's done. I don't have to go back and break it up and factor by grouping. No, leading coefficient is 1. So how do I factor this?
X plus 15. X plus
Good. So there are two possibilities. X to be 15 plus 15 will not be 0. So I have to write x plus 15 equals 0, which makes it negative 15, and the same for x equals negative 4. However, I use the principle of powers. No one knows if these are correct or just a byproduct of the principle of powers. So I have no choice but go back to the original problem and make x negative 15, and let's see what we get. So negative 15, this is going to be a positive number with minus in front. So negative 15 minus a number equals negative 8. But this is positive with minus in front. Is that possible? No. Let's check. Negative 3 times negative 15 is positive 45. Positive 45 plus 4 is positive 49. This is 7. Negative 15 minus 7, is that negative 8? No. As we expected, not. So now I'm checking negative 4. So let me use negative 4, negative 4. Negative 3 times negative 4 is positive 12, plus 4 is positive 16. The square root of 16 is 4. With minus in front, is negative 4 minus 4 negative 8? So then I have to say yes. I checked. Okay, let's look at 16. But I would like you to work on 16 for a minute. So 16, here's the equation. The square root of 2x minus 3 equals 3 minus x. I'll take my attendance. Do we need more time? I think you're more alert after the experiment. Everybody disagrees, I think. Okay. Maybe I should come up with something every class. Okay, got it. Got it. Got it. Okay, can anyone just tell us what to do? What is the first step here? Excellent. How come that I don't cube both sides, but I square?
There's no 3 in front of them.
Exactly, because it's the square root, which is power 1/2. Good. What do we have on the left?
2x minus 2.
What do we have on the right?
9 minus 6x plus x.
Good. Back to a quadratic. I'm going to have to set it equal to 0. So I subtract 2x and I add 3. So I have x squared minus 8x plus 12 equals 0. So x squared has positive. 2x, negative 6x minus 2x would be negative. And then when I add 3 to both sides, I get 12. Leading coefficient 1, not too difficult. How do I factor this?
X minus 6.
Okay, good. So x equals and 6. I have no idea. I have to go back and check, and I will check. Not here. This is not the original problem. This is the original problem. That's where I have to go back and check. So I plug in 2. So 4 minus 3 is 1. 4 minus 3 is 1. The square root of 1 is 1. 3 minus 2 is 1. I'll say yes. Now I check 6. I already know it's no, because the right-hand side will be 3 minus 6, which is a negative number. But I know that the square root is always positive. So 12 minus 3 is 9. The square root of 9 is 3. But this side is negative 3. So I will say no. So the only solution is 2. Any questions? Any questions? Let's look at a few more. Okay. 36. That is the cube root of x minus 4. Minus 5 equals negative 7. There is no need to copy the next one till we finish this. But I'm going to write one more. First step? Of course. Next step?
Cube both sides.
Because I want to remove the cube root, which is power 1/3. The left-hand side is? The right-hand side is? Good. So I add 4 to both sides, and I get this. I know it's going to work because it's an odd index, but I still have to go back. Okay. -4 minus 4 is -8. The cube root of -8 is -2 minus 5 is, as expected, it's a yes. Okay. Now, notice that this particular equation has 2 radicals, but no other term attached to those radicals. It's a special case. I do have 2 radicals, but I don't write this because I'm going to erase it. I don't have something like this. Let's say 3. Okay? I don't. So there are just 1 radical on one side and 1 radical on the other. They have to be separated. If they're not separated, it will be impossible for me to solve. Absolutely impossible. They are separated. So let's give it a shot. 1 minute. Mike, you want to say something?
No.
So what will you do? What do you think?
Square both sides.
Right. I will square both sides. And let's see what we get. The left-hand side is,
3y.
the right-hand side is
7y
7y minus
minus 6.
6. What type of equation is this? So I bring 7 to the other side. It's going to be negative. So -4y. And the other side -12. So y equals? Good. So let's give it a shot. So 3 here and 3 here. 3 times 3 is 9. 9 plus 6 is 15. So the left-hand side is the square root of 15. 21 minus 6 is 15. So the right-hand side is the square root of 15. Do we accept 3 or not? We have to. Yes. Okay, the next level is a little bit more difficult, which is the last level here. So that's the last one. In which, and I would like you to watch one problem, and then we'll work on many more. So, for example, 44. Let's start with 48. This is not a trivial equation. So notice that this would be a repeat of what we just did, and you would not have any difficulties, right? When I square, when I have 2 radicals, they are separated, I square and I'm done, right? But this, it creates a lot of steps, I would say, the fact that I have another term in there. So now, can I move the radical here, this one here? Yes, I can, but it's not recommended. The best thing to do is have them separated. What happens if I have 3 radicals? Well, I have no choice. 1 has to be on one side and 2 on the other, right? But in this case, when I have 2, the best thing to do is have 1 on one side and 1 on the other. It will be easier to square. Can I put them here and still get the same answer? Of course. But it will be more difficult to square something like this, the square root of 4x plus 1 minus the square root of x minus 2. I don't recommend that. So as you see it, I'm going to square it. And if I go back for a second, if you allow me to, this is why we did this. That's why we did this. That's why we did this. Because it's exactly what you see here. So let's go back. See? It's the square root of x minus 2 plus 3. Here I have the square root of 3x plus 1 plus 2. So I have to obtain these three terms. One coming from this squared plus 2 times 2 times the square root, which is this term, plus the second term squared, which is this. That's why we studied this piece last time. So what will you tell me on the left-hand side? What should I write? Take it easy, slowly, remember the agreement, and tell me what to write. The first term squared plus 2 times 3 times the square root. 2 times 3 is 6. The square root plus the second term squared, 9. The right-hand side is nice. What do I have on the right-hand side? Good. However, as you see, did I get rid of all radicals? If I had gotten rid of all of them, it would have been a terrible mistake somewhere. I can't. If I have two radicals, or if a radical equation has two radicals, there is two levels of squaring. If you eliminate both radicals in the first step, something is wrong. You did not use the correct agreement, right? You probably said this squared plus this squared, and that would be terrible, because that's not true. It's this squared plus 2 times the first times the second, or times the second times the first. It doesn't matter, which is this term plus the second term squared. So here's our first note here. Note. Solving radical equations with two radicals means, or involves, if you want, squaring twice. Very important note. If you square once and you get rid of both radicals, something is wrong. Except, let's go back for a second, except in this situation, where there is no free term. Okay? In this situation, yes, I squared both sides and I got rid of both radicals at once. But here I cannot. If I have a situation like this with two radicals and some term that has no radical on it, I have to square it twice. So here's my step. So I got here, I squared this side, and I got these three terms. 1, 2, 3. There are more. There's 4. But one term, the second term, and the third. I squared this, and I got 4x plus 1. What do you recommend we should do next? Because now we are back. Now we are back to this, in which I have one radical, and everything else is on the other side because I need to isolate the radical. It's a must. I won't be able to square if I don't isolate the radical. So then what would you do here? Keep the radical on this side and move everything else. Everything else has to go. Now the question is, what is left on the right-hand side?
3x minus 6.
3x. I agree with 3x. And that's, this is 7 minus 6. I agree with both. Because 9 minus 2 is 7, and I bring 7 to the other side, it's negative. 1 minus 7 is negative 6. What do you think I'm going to do next? And remember the two key words in this class. What are the key words in this class? And the other one is factor. So what will I do here? Of course. Yes, but by 3. I don't want to have fractions to deal with fractions. So 2, the square root of x minus 2 equals x minus 2. Do I really have to simplify? No, but it's wiser, because otherwise the numbers will get much bigger. What do I have to do next? Exactly. That's the second time. Now all radicals should go away. So in the first step, I squared, but one radical from the middle term is still left in the problem. Then I isolate that radical, moving everything to the other side, and now when I square, that last radical will go away. So what do we have on the left? Now I have to be very careful because this is a product, and we know how to square a product. How do I square a product of two factors? I square each factor. So you cannot write 2. You have to write 4. Now I have to write parentheses, because if I omit parentheses, then I change the problem. Because that 4 has to be distributed now. What do I have in parentheses? And now the right-hand side, careful, because the right-hand side is our contract from the first day. What do I write? X squared minus 4x plus 4, because it's 2 times the first times the second. Good. So what type of equation is this? Quadratic, but I have to distribute first. 4x minus 8 equals x squared minus 4x plus 4. And now I bring everything to one side. So I have x squared, I'm subtracting 4x, so then I have negative 8x, but I'm adding 8, so I have 12. We just had something similar a minute ago. I know how to factor this. How do I factor it? Yes, very good. X minus 2, x minus 6. So x equals 2 and x equals 6. I have no clue. Maybe. One may work, both may work, or none. It's very possible. A radical equation doesn't have to have solutions. Let me just check the time here in my video. Oh, 27. Let's go. Okay, so I go back to the original problem, which is this. And I check 2. Plug it in everywhere. So this is 0. 2 minus 2 is 0. So the left-hand side is 3. 8 plus 1 is 9. The square root of 9 is 3. I'll say yes to x equals 2. Now I will plug in 6. 4, the square root of 4 is 2. 2 plus 3 is 5. 24 plus 1, 25. Square root of 5. I'll have to say yes to both. Yes to 2 and yes to 6. This is not a trivial problem. I don't think that all my pre-calculus students will be able to do this problem correctly. It's not trivial. So let's work on a few more. So let's say 50. Now, why is this problem in a way difficult? Look at how many steps it has. First of all, you have to make sure that the radicals, for simplicity, not necessarily, but for simplicity, make sure that they are separated. Then you have to square, and you have to remember 1, 2, 3. You square this side. Then you have to remember that you have to isolate this and move everything to the other side. Then we simplified. Then we squared again. And then we combined like terms. We put everything to one side. We set equal to 0. We factored. And then we went back to check. A lot of steps. Okay. So 50, the square root of x plus 1 minus the square root of x minus 1 equals 2. So let's work on this for 1 minute. Let me know if you need anything. Can anyone just give me the first step? Just the first step. Absolutely. Absolutely. Excellent. Very good, Jackie. Yes. This is what I would have done. Is this the only way? No. But this is what I would have done. And then the second step. I just want to write it and I'll let you finish it. What am I doing next? Right. I want to emphasize something else here. If you could pay attention for 1 second. Another note. Look at the following. 2 plus 3 is 5. Agreed? What if I make the mistake of not squaring the left-hand side as 1 unit and the right-hand side as 1 unit? What if I think that will that work? What is this? What is this? What is this? Does this work? No. So the other note that I would like to add in here is, because I've seen it in papers, homework, tests, final exam, never square term by term. You cannot do that. It's not true. So that's why you have to square the left-hand side as 1 unit and you have to square the right-hand side as 1 unit. Because if I tell you 2 equals 2, then I can do this. Right? Okay. So can anyone give us the next step? Good. Yes? Right. And plus? Exactly. Very good. Excellent. So now what will I think of doing?
Make one side 0.
I cannot just yet. So I have to keep the radical and move everything else to the other side. So I have 4 the square root of x minus 1. And please tell me what we have on the left. Subtract x from both sides. X goes away. 4 minus 1 is negative. 4 minus 1 is 3. When I move it to the other side, I get negative 3. So 1 minus 3 is? Let's check again. So x, I subtract x from both sides. But here I have 4 minus 1. But 4 minus 1 is 3. I have to move 3 to the other side. 1 minus 3 is negative 2. Now let's look at this equation. Do we notice anything here? What type of number is the right-hand side? For sure and always. Positive. What type of number is the left-hand side? Can I find a positive number that equals a negative number?
Yeah.
Let's say we don't notice that. Let's say we don't see that. Oh, when I'm trying to finish up, I may not see it. It's possible. How do I proceed? How do I continue? Right. Let's see, I don't see that. The left-hand side is? Careful. 4. The right-hand side, I should have divided both sides by 2. If you did that, then you're right. I talk too much. I know. So the left-hand side will be 16 multiplied by x minus 1. I should have done that. So then 4 equals 16x minus 16. I move 16 to the other side. 20 equals 16x, and x equals 20 over 16. I will simplify by 4, of course, and I get 5/4. Do you think 5/4 will work in the original problem? It can't. It can't, because I got into this stage in which a positive number equals a negative number. So I go back, I copy the original problem, the square root of x plus 1 equals 2 plus the square root of x minus 1. Oh, I'm sorry, let me copy the original one. Square root of x plus 1 minus the square root of x minus 1 equals 2. Yes?
4x equals 16x minus. Never mind.
Is it okay? I'd rather go back and check if you see something. You may be right, I may be wrong. So 5/4, I'm checking 5/4. 5/4. So let's see. 5/4 plus 4/4 is 9/4. Square root of 9/4 is 3/2. 5/4 minus 4/4 is 1/4. The square root of 1/4 is 1/2. 3 minus 1 is 2. 2/2 is 1. Is 1 the same thing with 2? No. The equation has no solutions. We knew that from the beginning. Any questions? Any questions? I wouldn't say from the beginning, but we knew that from here, from this step, in which a positive number, I know it cannot be equal to a negative number. And even if I try this procedure, I still have to go back and check, because this procedure is not 100% legitimate. It may give us solutions like this one that do not work in the original problem. Okay, so let's talk about again about the Pythagorean theorem. Pythagorean theorem. And I know you remember it as a squared plus b squared equals c squared. That means nothing. It means nothing. Because if I name the triangle like this, CA and B, c squared plus b squared does not equal c squared. So a squared plus b squared does not equal c squared. So what I would like you to remember is not notation. I would like you to remember the leg squared plus the other leg squared equals the hypotenuse squared. So in short, the sum of the shortest legs squared equals the longest side squared. That's how we would like you to remember it. Because for this situation, the hypotenuse is b, so that's b squared, and the legs are a squared plus c squared. So this is how we should remember the Pythagorean theorem. The sum of the shortest sides, or the legs squared, equals the longest side, which is the hypotenuse squared. So I like to apply this in 54 on the same page, 630. And we have the right angle is here. We have 4 centimeters one leg and 7 centimeters the other. And we are asked to find the side that is unknown. I'm going to call this x. So now I have to think and say, okay, the sum of the squares of the legs equals the longest side squared. So can anyone dictate what we should write? Excellent. That's all I want you to say at this step, at this stage. The sum of the two sides that form the right angle, these are the shortest, also called legs, must equal the hypotenuse squared. Very good. So now I know that this is x squared, and I get 16, and I get 49, and then I subtract 16, and I get 33. And now I have to think, what procedure am I applying now? I'm not raising to both sides to a power. I'm applying the square root to both sides. Every time I apply the square root, remember, I should get the absolute value of x equals the square root of 33. We omit this step, and we go directly to writing x equals plus or minus the square root of 33. But yes, if you say, wait a minute, we're talking about a distance here. You cannot consider the square root of negative the square root of 33, and I would have to agree. So the leg measures the square root of 33 centimeters. Any questions? Any questions? Okay, let's look at a word problem here in which we have a right triangle to apply Pythagorean theorem in. Let's say 62 on 631. A wire is to be attached to supported telephone pole. Okay. Because of surrounding buildings, sidewalks, and roadways, the wire must be anchored exactly 15 feet from the base. So this distance is 15 feet. Telephone company workers have only 30 feet of cable, and 2 feet of that must be used to attach the cable to the pole. So I'm going to say that this is the 2 feet. And they have a total of, it says, workers have only 30 feet of cable, and 2 feet of that must be used to attach the cable to the pole and to the stake of the ground. Fine. How high from the base of the pole can the wire be attached? So one more time, it says that 2 feet are reserved for something else. So, oh, I'm sorry. This is not what I meant. I meant to write x. See, too much entertainment. That's what it is. Just kidding. Okay, so how long is the wire? We only have 30, but we have to use 2 feet for whatever else. So this must be 28 feet. So we are asked to find x. How high on the telephone pole they have to attach the wire? Again, you have to be very careful how you write the Pythagorean theorem. It has to be the sum of the legs, which is 15 squared plus x squared equals 28 squared. The sum of the legs squared must equal the hypotenuse squared. The same thing, x squared equals 28 squared minus 15 squared. And here's a question for you.